Okay, so we are starting. Is my screen visible?
Yes, sir.
Okay. So first question, it is given that XD is a metric space. It is given that Y and Z are both are subset of X, such that Y is contained in Z, which is contained in Y closure. It is given that Y is connected. So we have to show that then Z is also connected. So any idea how to prove? So what do you mean by connected space or connected metric space? Any idea? So for connected, we need disconnectedness. So generally we will define what is disconnected. And then we say that if a set is not disconnected, it means it is connected. So disconnected means say X is said to be disconnected if there exists a set say A, B calls the separation such that say X is A union B, where say A and B are open and A intersection B closure is empty and B intersection with A closure is also empty and A and B both are non-empty set. So if we are able to find any two open set in such a way that then we say that our metric space is disconnected, otherwise it is connected. So now we have to prove that Z is Z is connected. So let us assume that Z is disconnected. It means for Z you are able to find two open sets Z is equal to A union B, which are satisfying this condition. Right? Now how to proceed? Any idea? See, you know that Y is subset of Z, which is A union B. So it means Y is contained in A union B. And you know that these two are disjoint sets. And you know it is given in our question that Y is connected. Then you know that there doesn't exist any separation of Y. It means either since it is given that Y is connected, it is given. And they are separation. So it means either Y is contained in A or Y is contained in B, right? So now without lot of generality, we are assuming that Y is a subset of A. This will imply that Y closure is subset of A closure, right? And you know that Z is subset of Y closure. It is given in our question that Y is subset of Z, subset of Y closure. It means Z is contained in A closure. And you know that A closure intersection B is empty, right? So this will implies that our B set is empty, which is a contradiction. Because here we are assuming that Z is disconnected. It means there exist two non-empty set A and B, which are satisfying these conditions. But since Z is in A closure, it means B is empty. So we get a contradiction. Any doubt? Any doubt?
No, sir.
So now second question is, we have to show that suppose xi's they are path connected. Each xi is path connected. Then we have to show that this product is also path connected. So now one observe one thing that this product can be uncountable, can be countable, can be finite. If you are able to prove that x1 cross x2 is path connected, then you are able to prove this product. You have to just change the indices. So our aim is to show that like for even if you are able to do for finite, I am here doing for finite just for your understanding. Same proof will work for any product. You have to just change from you have to change your index from finite to this index. So, you know there are some properties of path connected. So how will you show that like something is path connected in matrix space? Say this equal to x. Any idea how to show that this is path connected? How will you show that you know about path connected? Yes or no? This is very easy problem. You know path connected, yes or no?
Yes, sir.
So like we say that a say metric space XD is path connected. So if you pick any 2 points, say x1 and x2 belong to x, then if you are able to find a map from say 0, 1 to x such that f of 0 is equal to x1 and f of 1 is equal to x2, then we say that our this matrix any matrix space or any subset of matrix space is path connected. So our so first we will pick 2 points x and say x from this product I equal to y this xi and y again from this product xi. Our aim is to find a continuous function. So this function must be continuous. Our aim is to find a continuous function such from f from say 0, 1 to x such that f of 0 is say this x and f1 equal to sorry this y. So can you tell me that continuous function? So this x is of which form? How can you write this x? X equal to xi where I is in I and y equal to yi when I is equal to y. So you pick any xi, this will be in capital Xi. And similarly any yi, this will be in capital again xi. These are path connected, right? So there exists a function fi from 0, 1 to xi, not x. Say if you union is a finite x1 cross x2. So we will use explicitly x1, explicitly x2. So since it is given that this xi is path connected, so we are able to find a function which is continuous such that f of I of 0 equal to this xi and f of I of 1 is equal to yi. So, but our aim is to find a continuous function from 0, 1 to x such that f of 0 is x and f of 1 is y. So now you have f. Now, can you tell me the function? the f from 0, 1 to x, which function we will choose? Can you tell me the function now? So we will define 0, 1 to x such that f of z is this, fi of z, where this I belongs to I. Now what is f of 0? You can easily show that this is continuous because each fi is continuous and using the coordinate wise. You can easily show. Now what is f of 0? This is equal to fi of 0 when I belong to I, right? Now what is this fi of 0? This is xi because we are able to find such fi. So basically this is nothing but xi. Similarly, you can show that f of and this is equal to x. Similarly, you can show. So hence our it means that product of any product of path connected matrix space is path connected. Any doubt in this question? Any doubt? Yes or no?
No, sir.
So now third question I think is very easy, but I will give an idea. So what is question number 3? It is given that A and B subset of R which are connected. We have to show that A intersection B is also connected. So first question is, you know that there is something special about connected subset of R. What type of subsets are connected in R? You know something like this? Yes or no? I am stating a theorem here. This is very, very important. That say a subset, say A subset of R is connected if and only if A is a singleton set or A is interval. You know about this theorem or yes or no?
Yes, sir.
So this is, so we will use this theorem here. So it is given that A and B are subset of R which are connected. It means A can be singleton or interval. Similarly for B. So A intersection B, what are the possibility of A intersection B? What are the possibilities of A intersection B? Can anyone tell me now? No idea. Say assume if A is singleton, B is singleton. What is the possibility of A intersection B?
Phi or singleton.
Phi or singleton, right?
Singleton.
If one is singleton, one is interval, what is the possibility? Say suppose A is singleton and B is interval, or A is interval, B is singleton. What is the possibility?
Pi or singleton.
Right?
Singleton.
If both are interval, then you know that intersection of two interval is either empty or
Interval.
or interval. And you know that, so A intersection we have only three possibilities: empty set, singleton, or interval. And you know that all three are connected in R. So it means A intersection B is connected in R also. R also. So can you apply these result in R2? The A subset of R2 which is connected. B subset of R2 which is connected. Can we say that A intersection B is connected? Yes.
Yes, sir.
Yes. Okay. So say this is circle of radius 1, say. So I'm not in good diagram. Say suppose this is circle of radius 1. This point is 1. This point is a 2. Now I am making this circle. Says something radius, something here will be center. I am not worrying about the center and the radius. Is this A connected? Say this is A. Is this connected? Okay, let me.
Yes, sir.
Say suppose this is. I am not worrying about center and radius. Is this connected? Say this is our set A. Is this connected?
Yes,
Circle.
sir.
This is our set B. Is B connected? This orange, this B connected. This is again a circle with some, say, with some center, with some radius. I am not worrying about that. This is also connected. Now what is?
He has led a yes.
What is the intersection B? This point and this point. Is this connected? Now A intersection B have only 2 points. Is this connected?
I would like to. Yes, sir.
Someone is saying something. Yes. Please tell me.
Sir, how to show that A is connected?
You know that every path connected is in metric space, in every, like in R2, every path connected is connected.
Yes, sir.
You can easily show that circle is path connected. Any circle with any radius is path connected. You can always find a path along with circumference. So this is circle. Your one point is this, one point is this. You have to reach from here to here within the set. How will you reach?
Via circumference.
Right?
Yeah.
So you can easily show that every circle is path connected. And you know that path connected implies connected. So circle is connected. Now, is there any path between these 2 points? Can you find? So I'm saying this is like this blue one is A. Our orange one is B. You know that both are circle, both are connected. Now their intersection will have these 2 points. One point is this, one point is this. Can you reach from one point to another point in this set intersection B? So I am saying that now my A intersection B, one point is this. This is my A intersection B. Is there any path in between them? Yes or no?
No.
No, there is no path. There are two distinct points. There is no path. A intersection, we have only 2 points, and you can't reach from one to another using a path. So just remember, like any finite set in R2 is not connected. Say here we have to, suppose we have 10 scattered, or you can't, if we have finite point, you just draw them in R2. You can't find a path because they are all distinct. There must be some length between these two, so you can't find a path. So remember this thing. This will help you in by use if you want to construct some counter example related to connectedness in Rn. In R we have a single real line, so we have a luxury. So just that's why you will see, say in, so first I will comment here that any finite set in Rn is disconnected. So in R similarly we have a result. Either we have a connected set, we have a singleton. If you are saying that you have one other point, then it must be an interval. So like using some theory, that's why in R also we have either singleton or an interval, not 2 or 3 points, either singleton or interval. So just remember these things, that a finite set in Rn is disconnected. This will help you in, if you want to some like construct some counter example related to connectedness. Okay. So now fourth question is very easy. I am just doing one part. It is given that f from x to y, where x is connected with any metric. It is given that y associated with discrete metric. It is given that f is, we have to show that f is continuous if and only if f is constant. So how will you show that? First assume that f is continuous. It is given that x is connected. Continuous maps connected set to, there is some property. You know that continuous map connected set to connected set? Yes or no?
Yes, sir.
Yes. So since it is given that x is connected, so this implies that fx will be connected, right?
Yes.
And you know that in discrete metric, there are only singletons which are connected. That's all in discrete metric. So it means that f of x must be equal to some constant. Means f of x is connected set. You know, it means that this will be a single point. So it means that your f is constant. Sorry. Now, conversely, assume that f is constant. So now you have to show that f is, it means that say f of x equal to say some c for all x belongs to x. This means your y must be in R or C, because we are discussing about the constantness. I think we can skip. Okay, sorry, we can skip this. This element is fine. So you have to show that f is continuous. So we have to show that, you know, like let u be any open set of y, then you have to show that f inverse u is open. So what is the possibility of f inverse u? See, if this c is belongs to u, then f inverse u will be whole x. Yes or no? Because your function is constant, right? I'm saying that if this c belongs to u, then f inverse u is whole x, because your function is constant. right? And if C doesn't belong to U, this implies that F inverse of U is, then what will be the F inverse U?
Single.
Singleton? Then what will be the F inverse U? Just think little bit. Empty set or not? This will be an empty set or singleton? I'm saying that
Empty
F
set.
inverse U empty set because only C have pre-image. Apart from C, we don't have element that have pre-image. Now, first case you assume that C belongs to U. It means that F inverse U is X because every element maps to C. We are assuming that C doesn't belong to U. Now U may consist a 1,000 crore, any uncountable point, but there does not exist any element in X which have image C because we know that Fx is a constant function. So it means F inverse U is empty and both are open because X is open in X and phi is always open in X. This implies F is continuous. So the fifth question, we have given that F from R to R. F is from R to R for any A belong to R. F of A such that F of A of X equal to F of X minus A. It is given that for any A belongs to R, we define a new function. This is called a translation map. So A part, I am just doing A part, B part will be similar. You have to replace continuous by uniform continuity test. So F is continuous if and only if whenever An is this is a sequence of real numbers such that An tending to 0. This will implies that F of An pointwise. You know the difference between pointwise convergence and uniform convergence?
Yes, sir.
Again, that epsilon will depend on X and when you write the definition. That is the difference between pointwise and uniform. So first assume that F is continuous. So now let X naught belong to R be arbitrary. So now we have to show that if there exists a sequence An tending to 0 in R, this will imply that F of An of X naught will converge to F of X naught. Pointwise means we need to discuss the convergence at each point. So for each point, we will pick arbitrary point and we will show that F of An X naught converges to F of X naught. And this X naught is arbitrary. It means that this is F of An converges to F pointwise. Now it is given that F is continuous. We are assuming that it means this is continuous at X naught. So for given epsilon, there exists a delta. This will depend both on X naught and epsilon such that Fx minus F of X naught is less than epsilon when X minus X naught is less than delta. Now we are given that An tends to 0 and we have to show that F of An tends to F of An of X naught tends to F of X naught. Now An tends to 0 means again for this epsilon there exists some stage N naught belong to N such that, sorry, I think we need some modification. Okay. Now this delta is a positive number, right? So for this delta, now we will apply the definition not for because later on we need to we need some comparison. So this delta is again a positive number. So by the definition of limit, even for this delta, there exists a stage n naught such that an minus 0 is less than this delta for all n greater than equal to n naught, because this is a positive number and we can apply the definition of limit to any positive number. Okay. So like now because we have to discuss the limit. Now our aim is to show this, that f of an of x naught will converge to f of x naught as n tends to infinity. So so for limit we can discuss after a stage. So what is this value? X naught minus an, this will be mode of an, which is less than delta, right? So consider this x1. So it means x1 minus x naught is less than delta. So by the definition of continuity, if some x minus x naught is less than delta, that will imply that mode of fx minus f of x naught is less than epsilon. So from here, can I say that f of x1 minus f of x naught, this is less than epsilon, where x1 is x naught minus an. So is this true or not? Is this true or not? Anyone have any doubt in this step? See, we want to compute this difference, mode of x1 minus x naught, where mode of x, sorry, where x1 is x naught minus an. So this x naught will cancel out. This is equal to mode of an. And we are discussing this after this stage. We know that when n is greater than equal to n naught, our an is less than delta. So we are getting that mode of x1 minus x naught is less than delta. Now by the definition of continuity, if this difference is less than delta, then their functional difference is less than epsilon. So we can write that mode of f of x1 minus f of x naught is delta. Now this will be, just substitute the value of x1, x naught minus an. So can you write this? What is this value f of a and f of x naught? How's the initially function defined? F of a of x equal to f of x minus a. So this value is exactly equal to f of a n of x naught. And this is less than epsilon for all n greater than equal to n naught. This will implies that f of a n will converge to f pointwise, because we are able to show for any arbitrary x naught. Same thing will work, just you deal with the uniform continuous. Just apply the definition of uniform continuous. This x naught will be go away. You have to just then using the Cauchy sequence, you could easily show that when if f is uniform continuous, then the same results hold also. Now I think this is the, just give me a minute. I need to check whether this is converse part or not. Yes, this is an if and only statement. So now we will show the converse part. So assume that an is a sequence of real number which converges to an tends to 0. This will implies that f of an converges to f pointwise. Whenever this type of situation arise, that an tends to 0, this will imply that f of an converges to f. Then we have to show that f is continuous at r. Means f is continuous at every point. So there is some definition of sequential definition of continuity. Can anyone tell me that definition? Say again, like say choose any point x belongs to R, any point. We have to show that f is continuous at x. So there is a definition. One definition is epsilon delta. There is some definition related to sequence of continuity. Can anyone tell me? No one knows the sequential criteria. There is some sequential criteria. You can show this by using some sequential criteria also.
So can you explain previous part again?
Okay. We have to show that f is continuous if and only if whenever this an tends to 0, this implies that f of an tends to f pointwise. So first I am assuming that f is continuous. Now I will prove this part. This part means whenever an tends to 0, we have to show that f of an tends to f pointwise. Pointwise means we have to show for each x belongs to R. So I will show for arbitrary point of R. Then it means that this is true for all point of R. So it is given, assume that an tends to 0 in R. Okay, sorry. This is mistake. As n tends to infinity. So first it is given that we have to show this part. It is given that f is continuous at x naught. Okay. So for given epsilon, we are able to find a delta such that f of x minus f of x naught is less than epsilon whenever this difference x minus x naught is less than delta. This I just apply the definition of continuity at x naught here, nothing else. Now it is given that an tends to 0. This delta is a positive number. So for this delta, we are able to find a stage n naught such that this an minus 0 is less than delta for all n greater than equal to n naught. Right? Here I just apply the definition of limit. That what is the limit of an? What do you mean by limit of an equal to 0? That's all. I just apply that definition. Now for any n greater than equal to n naught, first focus this. Our x1 is assume that x naught minus an. And our x naught is x naught. What is this difference? X1 minus x naught. What is this value? Tell me.
An.
Mode of an, right?
Yes.
But we are not computing for all n. We are computing only when n is greater than equal to n naught. But when n is greater than equal to n naught, our mode of an is less than delta. So
Delta.
it means that this difference x1 minus x naught is less than delta. So when x1 minus x naught is less than delta, so just see the definition of continuity. When this, focus on this. When the difference of any number with x naught is less than delta, that means that difference of their functional value is less than epsilon, right? So since x1 minus x naught is less than delta, this will implies that f of x1 minus f of x naught is less than epsilon. Okay. So now what is the value of x1? I just substitute the value of x1 here. X naught minus an. And this is nothing else. This is the definition of f of an of x naught. We defined f of a of x equal to f of x minus a. So when you just open this f of an minus f naught, f of a f an of x naught, this will be f of x naught minus an. So it means, and this is true for all n greater than equal to n naught because we are computing this. So it means that fn of x naught converges to f of x naught by just the definition of epsilon. It means, and your x naught is arbitrary. That means that f of an converges to f pointwise. Now you understand?
Yes, sir.
Now I'm saying that we need to prove the converse also, like that if we are given that an tends to 0, this will imply that f of an tends to f pointwise. Then we have to show that f is continuous at R. Means f is continuous at each and every point of R. Again, like this, pick this point be arbitrary. Then we have to show that f is continuous at x. So I am asking that there is some sequential criteria of continuity. to show that a function is continuous at a given point, there is some sequential criteria. Can you please tell me that? You don't know the sequential criteria. Yes or no? See, we have to show that f is continuous at. I am just stating the theorem. Just tell me whether you see this result or not. If xn converges to a, this will imply that f of xn converges to f of x, then f is continuous at x. Did you see this result or this type of result or not?
No, sir.
Yes or no?
No, sir.
No, you don't know this result. This result is not done in class. Like ma'am didn't give any exercise. I'm quite surprised. Can anyone else tell me? Someone knows this result or not? Saurabh, did you see this result?
I guess no, I don't remember.
Just see the notes. This result will be there. I am very much sure. This is the one of the basic result in the continuity section. Like if you want to show that f is continuous at x, I think this is even done in MTL100. I know very well that this is even done in MTL100. I am 100% sure for R. Same things will hold for metric space. I am pretty much sure this is in MTL100 for R. Same things will hold for even in a general metric space. So if you want to show that f is continuous at x, if you this is called the sequential criteria. So you assume that xn converges to x, and then show that fxn goes to f of x. It means f is continuous at x. This is the sequential criteria. So we will use this sequential criteria here. So we have to show that f is continuous at x. So assume xn goes to x. Then xn minus x will goes to 0. Right? But we have this result. If an goes to 0, then f of an goes to f pointwise. It means this. Consider this now is an. F of an goes to f pointwise. Pointwise means this convergence is true for every x. So for every element of x, particularly for this x also, f of a and f x converges to f of x. Right? What is this value? Just tell me what is this value. Because we know that f of a of x equal to f of x minus a. So I just substitute this value. What is your an? Xn minus x. This x will cancel out. I think there is some mistake. Let me see the definition. I think we need x minus xn. I think we can do. Even this will work. This will work in. You know that when xn goes to x, then xn minus x will also goes to 0, and x minus xn will also go to 0. Because we need f of xn in our left hand side. So this will be f of xn goes to f of x. Here just you need to just use the sequential criteria, then the result follows immediately. Now any doubt in this question? See, practice this type of questions. This type of question will most probably come in. I'm pretty much sure this type one question of this type will come in major. This is my expectation. Like here you have to use the convergence in R, convergence in metric space, and the sequential criteria of continuity also. Like you have to use 2-3 concepts. So this type of question will probably come. One question related like this in this type of setting. So practice this type of questions. And you write there is some sequential criteria, there is some like for uniform continuity there is some Cauchy criteria. Write all the results so that you can use directly. Just state the results in exam and you can use directly them. In any book you can easily find all the sequential criteria, limit criteria, epsilon delta definition in a single theorem. You can easily find in any standard book. So just remember those results. What is now next question? So sixth question is n equal to 1 to n minus 1 by n. We have to show that this series converges uniformly in every bounded interval, but doesn't converge absolutely for LD value. So you can just split this series. So this will be xn by n square plus c. When the interval is bounded, is this series convergent uniformly? So interval is bounded means x belongs to some minus m to m. Is this series converges absolutely? Sorry, I made a mistake. I think this is x square. When the interval is bounded, is this series converge uniformly? Yes or no? Yes or no? You know about the uniform convergence of series? You know about some Weierstrass test? Did you know Weierstrass test?
No,
Yes,
sir.
sir.
No, sir, no. So how, like, which results ma'am discuss of uniform convergence? Can anyone tell me one standard result which ma'am discussed in the class? Did ma'am discuss uniform convergence of series in class?
Yes, sir.
Yes. So did ma'am discuss some result related to them or say some test related to them?
Yes, sir. The Vestas M test has been discussed in class.
In the discussion, why are you saying that that is not discussed? I think most of you missed the class. See, because you know that when x belongs to this minus m to m, this x square will be bounded by m square, right? And you know that minus 1 upon n to power n square, this is a convergent series. You can Weierstrass test, you can easily see because this x square will be bounded. When you and this series is finite. Did you this in the Leibniz test of alternating series? You can easily show that this series is finite. This is an MTL100. I think you did in the MTL100. This is alternating series test. One test is called Leibniz test, and you can show that. Just give me a minute. Sorry. This series is convergent. And this series is convergent by Weierstrass test. This means that this series is absolutely, uniformly convergent for any bounded interval. Now, just one line argument. Can anyone tell me that why this series is not absolutely convergent? Means when you take the modulus, why this series is not convergent? Can anyone tell me?
One by n is divergent.
Exactly.
The second part, when you take the modulus, this will be 1 by n. Now you know that when you take the modulus, this is again a positive series. This may be positive or maybe infinity, it doesn't matter because this is infinity. So the result is divergent. That's all. That's you need to write in just mathematical. See, the series questions will be very easy. I am getting some message from you. We'll see later on. Give an example of discontinuous function. So seventh question, we have to say give discontinuous where k belong to this n. These are all discontinuous. Such that fk converts to f. Uniformly in R. We have to construct a family of discontinuous function, means f1, f2, f3, f4, f5, all are discontinuous at some point. It may be possible that 1 point, 2 point, we will see, but we have to show that fk converges to f uniformly in R and this f is continuous. Can you construct a family of discontinuous function converging to a continuous function uniformly? Is it possible? Yes or no? Is this function continuous at 0? Is the above function is, or you can say that these two functions are continuous at 0 or not? Am I audible? Am I audible?
Yes, sir.
This f1 or f2 are continuous at 0 or not?
No, sir.
This function is continuous at 0 or not?
No, sir.
Right? Because we have you when you evaluate left hand limit of f1, this will be 0. Right hand limit is 1. When you evaluate left hand limit of f2, this will be 0. Right hand limit is 1 by 2. Similarly, here left hand limit is 0. Right hand limit is 1 by 3. So this is a discontinuous at 0. So similarly, you can construct f of fk 0, 1 by k when x is less than equal to 0. Can anyone tell me what is limit of fk of x when k tends to, for any x, for any x? What will be the limit?
0.
See, if x is less than equal to 0, then all our fk's are 0. So this will be 0 when x is less than 0. When x is greater than 0, this when x is greater than 0, this fk of x will value 1 by k. But when we are taking the limit, then we will get the 0. So this is our function f. So we are getting our f is equal to 0 everywhere. Is this function continuous?
Yes, sir.
Yes, sir.
Yes. But
Yes, sir.
is our question complete now? See, these all our fk's are discontinuous and we are able to show that fk converges to f, which is a continuous function. Is our question complete? Here we discuss the limit pointwise or uniform?
Point 1.
Pointwise. But we need that fk converges to
Uniform.
f uniformly. So till now we are able to, you can easily show, you can just write in mathematical way, you can easily show that this fk of x converges to this 0 0 when x is less than 0, this will be limit of 1 by k. But here the limit is pointwise, then we have to show that limit of fk equal to 0 uniform. And this you can do by Archimedean property, like I think like say let epsilon greater than 0. So we are able, we need to find a stage n naught depends only on epsilon only, not on any point, such that fk minus fk of x minus f of x, this will be 0. This is less than epsilon for all n greater than equal to n naught for all x belongs to R. So this will be 0. So basically we need to show this for all x. So this is I think k. Just don't confuse in these notations. See, by Archimedean property there exists n naught such that 1 by n naught is less than epsilon, right? Now what is the possibility of fkx? If x is less than 0, this is 0, right? And now we will show, we are discussing all this when k is greater than. First we will find, we have a epsilon in our hand. Then using Archimedean property, we will find a natural number n naught such that 1 by n naught is less than epsilon. Okay. Now I will show that this mode of fkx is less than epsilon for this, for all k greater than equal to n naught for this n naught. So if x is less than 0, then fkx is 0. We know this will always be less than epsilon. But when x is positive, this will be 1 by k. But you know that this will always be less than epsilon. But when k is greater than equal to n naught, 1 by k is less than 1 by n naught. And your 1 by n naught is less than epsilon. In both, in for every x, you are getting that fk of x is less than epsilon for all k greater than equal to n. It means your convergence is uniform. Any doubt in this? Any doubt in this? Here our n naught is depending on which factors? One factor is epsilon by Archimedean property. Is our n naught is depending on x here? Is our n naught is depending on any point here?
No, sir.
No, because we just pick, we just choose one condition that 1 by n naught is less than epsilon. That's all. So our n naught is depending on epsilon only. It means that your convergence is uniform. You just need to write this. So eighth question. It is given that converges uniformly. This series k equal to 1 to infinity. This family of function converges to G uniformly on R. It is given that h from R to R is bounded function. Bounded function. Then you have to show that this k equal to 1 to infinity h of gk, this will converge to hg uniformly on R to show. So first thing, it is given that h from R to R is bounded function, means there exists a m positive such that hx is say less than equal to m for all x belongs to R, right? It is given that this series converges to G uniformly. So I am defining the sequence of partial sum. S1 is G1, S2 is G1 plus G2. Basically just like you did in the numbering things, same thing we will do in the function type, sequence of partial sum. S3 is G1 plus G2 plus G3, so on. So some Sn is n equal to, sorry, it will be which notation, I think Sk, it will be better. Sk Gn, right? Now it is given that our series converges uniformly to G. So let epsilon greater than 0. Since this, from here you can conclude that Xa converges to G uniformly. So there exists a stage n naught belong to n such that Sk minus G is less than epsilon for all k greater than equal to n naught and for all x belongs to R. Because it is given that this series converges to G uniformly. It is given that this series converges to D. It means its sequence of partial sum will converge to G. It is given. So instead of epsilon, I will use epsilon by m here because epsilon by m is also a positive number. Now consider this h of Sk minus h of G. This you can write in this way, Sk minus G, right? This is less than m. This is less than epsilon by m. When this is less than epsilon by m, Sk minus G is less than epsilon by m. Not for all k, but for all k greater than equal to n naught, right? Just by the definition of uniform convergence. So this will be less than epsilon for all k greater than equal to n naught. And you know that this h of Sk will be the sequence of partial sum of this series, right? So sequence of partial sum converges to this. Sequence of partial sum converges to h of G. It means h of this gk will converge to h of G uniformly. Why uniformly? Because your this n naught is depending on only epsilon. Why? Because this Sk convergence is uniform and we are using the same n naught here. So since this convergence is uniform, this n naught will depend on epsilon only. This is just the sequence of partial sum. That's all. So now any doubt in any question? Any doubt? Yes or no?
No, sir.
Those who don't have any doubt can leave now. Those who have doubt can stay here.
Sir, can you explain question 6 again?
Okay. Question number 6. So this, see, this is, we have to show that this series converges uniformly when x belongs to a bounded interval. And this series is divergent when we take the absolute value. So first we will discuss the divergence. You can split this series in this and this, yes or no?
Yes, sir.
Now when we take the absolute value, what about this?
It will diverge.
And when we take the absolute value, this will be x square by n square. This will be a positive number. It may be zero. Sorry, not maybe zero. It may be finite or something, right? Or it may be
Yes, sir.
infinity. Doesn't matter. But this number is infinity. So the overall sum will
Diverge.
diverge. Okay. Now come to the first part. When x belongs to a bounded interval, means x belongs to some minus m to m. Say, I am just for your simplicity, it bounded interval may be a to b. So it's better to write this. Not because you are confusing. M1 to M2. My only point is that this x square will be bounded by a unique number or not.
Yes, sir.
That will be bounded, right? Then you just use And you know that this series n equal to 1 to infinity minus 1 by n square. This is finite or infinite?
Finite.
Just by Weierstrass test, you are getting that this series is uniformly convergent. And what about this? Now we are not taking absolute value. We are just discussing about this series. N equal to 1 to infinity minus 1 to power n upon n. This series is convergent or divergent? In MTL100, you read, I think, this thing. Convergent or
It will
divergent?
converge. Converge.
Converge. Why? Because this is an alternating series test, and by using the Leibniz test, there is
Leibniz
only one test for alternating series, Leibniz test. You are getting that this series is convergent. And there is no x here. It means that both are uniformly convergent. So the sum is uniformly convergent. That's all.
Okay, sir. Got it.
Any other doubt? Those who have doubt can stay here. Those who don't have doubt can leave the meeting. Like I have discussed the complete tutorial sheet now.
Sir, I have sent the doubt in the chat. Can you please read it?
First tell me who start the recording. Who started the recording without asking me? This is not right. So you are asking about the A part.
Yes, sir.
That Cx is a connected component of X. Then for each X, Cx is connected. Union of C. You know about the connected component?
Yes, sir.
So what is the connected component? Can you tell me?
It is the union of all those connected components which include X,
Yes.
Cx.
And union of connected sets is?
Union of connected set will be connected if their their intersection is not pi.
Okay. So you you automatically send me the proof. This Cx is just the definition that union of C connected, C contains X and C is connected where X belongs to C, right? This is the definition of Cx. Now each C is connected and is X is in the intersection of all these. Why? Because X belongs to each C,
ठीक है.
right? देखो हम इसमें वो सारे सी कलेक्ट कर रहे हैं जो कनेक्टेड है और जो एक्स को कंटेन करते हैं. सपोज देयर आर ओनली 5 सीज लाइक C1, C2, C3, C4, C5. So it means Cx is the union of C1, C2, union of C1, C2, C3, C4, C5. First of all the C1, C2, C3, C5, C4, C5 are connected. So their union will be connected if this is non-empty. And their union is non-empty. Why? Because X belongs to their intersection. Why? Because X is in C1 also. X is in C2 also. X is in C